Hello everyone, welcome to day 6. I'm going to continue with the hashing problem. So this last one was left. The question is to find the highest or lowest frequency element. The highest frequency 15 is 1. Okay, so we need to find both highest and lowest frequency element, and we are given an array. So we can simply do this using hash map. We can take a hash map data structure, and for each element we will check if the key is already present in the hash map, then we will increment the value. Otherwise we will add a new key with this value and add the value of that key as 1. And at the end we can iterate over the hash map and see which element has the highest and lowest frequency. So I'll write the code for this quickly. So here we are passing the size of array and then taking the array as input. And then we'll take a hash map integer, both of integer, key and values, and then for int I equals to 0, I is less than n, I plus plus. Either we can do this, what it is hovering here, that if map dot contains key, if the map already contains this, then we will only we'll get this value and increment it and put it in the map, else we will put 1 in the map. Or there is one more map dot put, this one I was saying. So there is one method in map called map.getOrDefault. We can use this method. So what it does is it will get the value from map. Okay, it will get the value from map for this key, and if it is not present, then we'll put the value as 0, the default value as 0 plus 1, whatever will be the result of this plus 1, and we'll put this in the map. Then we will loop through this. So map dot entry integer entry of map dot entry set, and then if entry dot so we need to check if, okay, we need to take the greatest and smallest value, right? So int max equals to 0, int min equals to 0, int max key equals to 0, int min key equals to 0. So now we will check if entry dot get value is greater than max, correct? So if entry dot get value is greater than max, then max will be this and max key will be this, is less than min. If entry dot get value is less than min, then minimum value will be this. and minimum key will be this, and then at the end we can print both max value and count and min value and count. Let's see. Oh, I need to print it in, oh my bad, I'll run this again. Number of elements 6. 1, 2, 3, 4, 5, 6. So the most repeated element is 10, which is on 3 times, and least repeated element is 1, which is 1 time. Let's see. The brute force approach is make a visited array, use the first loop to point to elements of the array, initially make the index true in the visit. Okay, so in brute force approach they are creating an array with all the elements and then visited as plus for that element. And optimal solution is use a hash map. Let's see the code. Okay, they are using the get not default, and this is also same. Oh, we can initialize a variable like this also. This I'm seeing for the first time. Max frequency and then comma and one more variable. I wasn't aware of this. Okay, and complexity will be order of n. Fine, mark it as closed. So basic section is complete. Then we have sorting. Okay, these are classic sorting algorithms. I want to do some interesting questions right now. Let's skip sorting for now. I'll do it later because I want to do some different questions, not the ones I already am aware of. Like sorting ones, these are classic problems. I'll do it later because I've done it long back, so I don't know if I remember merge sort and quick sort and all. So I'll do it, but not right now. Let's skip this and move to array questions. So first one is largest element. Given an array, we have to find the largest element in the array. Okay, so to find the largest element, one way of doing this would be to sort this array and find the last element. So that will take n log n time complexity. Other way of doing this would be we can do it in order of n by traversing this array one time, and we will take a variable called let's say current max, and we will make it as array zeros, the 0th index element, and then we'll start iterating from first element to last and see if we get a value greater than current max, then we'll update the current max to current value, and at the end we will have the largest value. So I'll quickly write it. Is this ID hearing what I'm saying? How come it prompts every time? Now this is scary. How come it knows what I'm going to do? Okay, or it knows it somehow knows like what is open in my Chrome. I have no idea. Every time it prompts exactly the same solution which I'm thinking or which the question I'm reading. Let me try to say something and see if it prompts the same thing. So I want to find the length of this array. the array I'm taking as input, I want to find the length of this array. Now let's see what it does. It's not prompting anything now. It is doing something. Let's see what it is prompting. Once again, for int I equals to array is given. It's still showing the code for this question only. So maybe it's connected to Chrome. I'll have to change this setting. I'll see if it has access to Chrome, then I'll change it. For int I equals to 1, I is less than n, I plus plus. If array of I, if it is greater than max, then we will update max. Array of I, that's it. And we'll return max. I think this is pretty simple. I'll quickly go, and the time complexity in this one will be order of n. Brute force is sort the array in ascending order and print the last element. Optimal solution is we'll keep max, and then at each iteration we'll check and update max. That's all. Second largest element. Let's see. So given an array, find the second smallest and second largest element in the array. Print -1 in the event that either of them doesn't exist. Okay, if there is only one element, then obviously none of them exists. So we can check that if size of this array is 1, then we will print -1. Otherwise it will always exist, right? Or it will not exist if all the elements are same. When all the elements are same, then we will not have second largest. So that also we can check that if all elements are same. And yeah, that's all. So now what we can do is sort this array, and then what we can do is we will take one pointer at the start, and we will keep traversing this until we get the element which is so let's say we'll take one pointer at the start and we'll name it current, and the value of current will be 1, which is the first element. Then we will keep iterating this array, and one point is the array is sorted. Okay, so we'll keep iterating until we have 1. Once we reach an element which is not 1, then that is the second largest. Similarly, we will do from backside to see the second smallest, and we'll do the same from backside to see the second largest element. And in case from the start to the end we don't get any element, like the current is this, but we are not getting anything other than this, then we'll print -1. So this will take n log n time. Okay, can we do better than this? So after sorting, we can do one more thing. So there is I think this sorting, I should have done the sorting once, because there is this sorting algorithm, selection sort or insert sort, in which we find the exact position of that element and then place it or replace it with this. Yeah, correct. So we don't I think we don't need to sort it, which will take n log n. The better approach would be I think that's called a selection sort. So once we are at first element, let's say we'll take some other example. for clarity, because in this example first element is the smallest. So I'll take some other example. So let's say this is 10 and this is 20 and this is 4 and this is 5. Okay, so what we will do is, we are at first index. Now we will iterate from second index to last and find the smallest element in this, and or we will find from this index only, because this could be the smallest. So we will take current as 10 and we will iterate over this, and then we will find the minimum element in this whole array. So when minimum will be what, we'll keep iterating and we'll find the minimum will be 4. Okay, then we will swap the first element and this element. So now what the array will become, it will become 4 20 10 7 7 and 5, right? Then now we are at second. Now we want to know which element will be there in this position, so we will take this as current. Okay, now current is 20, and from 20 to 5 we will find the smallest element, which is 5. So min will be 5, and then again we will do the swap between 20 and 5. So what will happen, we will get 4 5 10 this thing. Okay, so now we have got the element at second position when this array will be sorted, and this will be the smallest element. Similarly, we can do from backward to find the second smallest. So what will be the time complexity of this? We have traversed this array only 2 times when we are traversing from the start, and similarly we will traverse this only 2 times when we will traverse from the back. So 4 into n will be the order of 4 into n, which is order of n. That will be the time complexity for this. This is, I think, the best approach to do this, using selection sort. I'll check if it's called selection sort or not. Selection sort, what is selection sort? Selection sort is comparison sorting. It's sorted repeatedly, selecting the smallest element or largest element from unsorted position and swapping it with the first unsorted element. Correct. Okay, so that is correct. In place, sorting in place, comparison based on sorting that works repeatedly, finding the minimum element from the unsorted part of the list and swapping it with the first element of that unsorted region. Correct. Okay, so I'll write the most optimal solution for this. What we can do is, we'll take an element called current, which will be the first element, and then we will start traversing from the first element. I is less than n, I plus plus, and we need to find the smallest element, right? So if array I is greater than current, then current equals to array I. No, we need to find the smallest element in whole array, so I will take it as -1. No, this is not correct. I need to have the smallest, so I will take this integer dot max value, and then if array of this is array of I is less than current, then current is equals to this. Now we will have the minimum element in this, right? Now we have current as minimum. So what we will do at the end, what we will do, we will swap the values. We also need the index, right? So index equals to -1 and here index equals to I. At the end we will swap the values. So array of, will take a temporary variable in temp equals to array of 0, array of 0, array of index, and array of index equals to temp. So this is swapped. Now we have got the first smallest element, but we need the second smallest. So again we will run the for loop, but this time we will run it from 1 to n and again do the same thing. We will again do the same thing. We can run this in a for loop also, that should also work. So like this, for int j equals to 0, j is less than 2 j plus plus. In this way it will run only 2 times, and then we can do this inside this loop. And I will be, first it will run for 0th index, then first index, and we can do this at the start of this loop. Int current, and at the end we need to swap, so we will do it inside this loop. Not 0, this will be j and this will be j, that's it. And then at the end we have the smallest, at array of 1 we will have the smallest element. Similarly we can find the largest element by doing the same thing. I'll write this again. So from j equals to now we need j equals to n minus 1 till j equals to n minus 3 I minus j minus minus, and current will be, this time we will make current as integer dot min value, and index is -1. So int I equals to j I minus minus, I is greater than equals to 0, I minus minus, and we'll check if array of I is greater than current, then this will happen, and again we'll swap this. Now we have the elements, or we can just simply print the array. We'll check the second element, and second last element will be our result. Size of array is 3 4 5 6, then 1 2 4 7 7 and then 5. So the second largest element is 2. It is printing the same, isn't it? What if it's 10 9 8 7 6 5? 5, 10, 9, 8, 7, 6. So 6, 7, 9, 10. 6 and 7. This is printing correct, but this is not correct. Last element is 5, right? J equals to n minus 1. So j equals to 5. Wait, this should be j is greater than, right? Okay. One, two, what was that? 1, 2, 4, 7, 7, 5. 4, 7, 7, 5. Now this is correct. So the second smallest number is 2 and second largest number is 7. Brute force is sort these and find the element as first index and element at index length minus 2. Better approach would be perform a single traverser to find, this is what I said, and optimal approach will be we will need 4 variables. Second largest, if the current element is smallest, update the value of second small to small, else if the current element is smaller than second small, update the value to second small. After traversing the array, the second smallest element will be stored in the variable second small. This is similar only. This one we have on lead code. I'll do it on lead code. Okay, the question is check if array is sorted or rotated. Given an array nums and return true if the array was originally sorted in non-decreasing order and then rotated some number of position including 0, otherwise return false. There may be duplicates in the original array. Note, an array A rotated by X position results in array B of the same length such that bi equals to, okay, so this is true because this is sorted but rotated. 1 2 3 4 5. This is not sorted. Okay, so if I think about it, if we try to we'll get nothing if we sort it. Okay, we don't need to do that. What we can do is we can start traversing this array. Okay, and at each step we will check it should be greater than the previous element. But once we reach a point where the next element is smaller than the previous element, then it is allowed only one time. So we will take one variable called allowed or something, allowed rotations, and we will say that, or we will take a rotation, so we will say that it is rotated and it is allowed, so we will continue. But if we reach the end of this array, then we will check that this value should be lesser than the first one, right? If we have already rotated, otherwise it will be greater. Like this example, it is not rotated, so the last element should be greater than the first one. But if it is rotated, so it should 2 should come 3 should come after 2, so this value should be less than this. That we'll have to check if it is rotated one time. Else, if we encounter one more time this happens, that we get a smaller value after this, then it is not sorted and rotated, and we will return as false. So let's see. We'll take one counter, int rotated equals to 0. Okay, I need to do it in Java. So we'll take a counter, int rotated equals to 0. Then we will start traversing this array. Int I equals to 0, I is less than or I equals to 1, let's say. We can also do this also, that if let's say int n equals to nums I, nums dot size or length I think length. Now if the size of this array is 1, that means there is only one element, then return true. That is already sorted. Now we will make one more element equals to nums 0. Okay, and this will run till n I plus plus. Now we will check, now we will say that if element they can have duplicates, so it could be equal. Okay, so if next element is smaller than, if num size is smaller than, num size is less than element, then it means there is a change, right? So what we will do, we will check again. What if rotation is already done? So if rotated equals to 1, it's already done, then return false. We don't need to do anything, it's getting rotated second time, so we'll return false. Otherwise what we will do, we will make rotated equals to 1. Okay, and element will be the current value in all cases, so element equals to nums I. Even in case of rotated it will be nums I. Yeah, that's it. Now at the end we can check if rotated equals to 1, that means it was rotated one time, so the last element, and then we'll have to check if the last element, if nums 0 is less than what if it's equal, then rotated cannot be 1, right? Because all the elements will be 0 if first and last are same. So nums 0, if nums 0, that means the last element is less than nums n minus 1, is less than the last element, then also return false. Otherwise we will return true. Rotated. equals to. I want to check one more thing. What if there are only two elements, 1 and 2? And what if both the elements are equal? Okay, and what if it's in decreasing order? Fine, submit it. Okay, I'll see some solutions. But this solution, they are traversing till the end, right? Count plus plus. Why we need to traverse till the end? If we already have the solution, we can simply return. Okay, and mark it as complete. Next is remove duplicates from sorted array. Given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept same. Consider the number of unique elements in nums to be k. After removing duplicates, return the number of unique elements k. The first k elements of nums should contain the unique numbers in sorted order. What we need to return? After return the number of unique elements k. The first k elements of num should be containing. Okay, we need to update nums also in such a way that num should contain the unique numbers in sorted order. The remaining elements beyond index k minus 1 can be ignored. The judge will test your solution with this. Nums equals to input array expected nums. Answer with correct length. K is remove duplicates. Assert k equals to nums I equals to. Okay. Got it. So after removing the duplicates, we just one will be removed, so we will just have 1 and 2 in the nums. In this we will have 0 1 2 3 4. Do I need to make it as 0 or skip these? So one of the easiest ways of doing this would be we'll take a set in Java, because set contains unique elements. I guess set in Java contains unique elements, is it? designed to store only unique elements, right? So what we can do is we'll take a set and then put all the elements in that, and then it will contain only the unique ones, and then we'll iterate over the set and fill this array. That is one way of doing this. The second way of doing this would be, they are saying in place, but one other way of doing this would be, we'll iterate over this, we'll create one more array. So let's say this is the initial array, right? This is the initial array. We'll create one more array with the same size, and then we'll start iterating over this array, and we'll keep adding the elements in this. So let's say we are at first index, we'll enter this 0 here, and then from the second index we'll keep comparing. If this is equal to this, then we'll skip, we'll go to next. If this is equal to this, it is not, so we will enter the next value. Then we will compare this to the current element, it's equal, we'll skip this, then 2, we'll enter 2, then again, then 3, and then 4. So that is also one way of doing this, but in this approach we are taking extra space, but the time complexity will be order of n. Then the next optimal solution would be doing it in place without taking extra space. So for that what we can do is, we'll take an index, int index, and call it at 0. We'll place it as 0. They're saying it's already sorted, right? It is sorted, okay. So we'll place it as 0, and then we'll start iterating it from the first element. And we will check if this element is equal to the previous element. If it is equal to the previous element, we will not do anything. Then we'll check if this is equal to the previous element. We'll take index as 1 for simplicity. So index is at here, so we will check if this is equal to the previous element. It is not, so we will update the element at index 1 and update index, so this will become 1, okay, and then update index is 2, so index is here. Now we will check if this is equals to the previous element. It is, so we will skip. We will check if this is equal to, it is equal, then skip. Then we'll check if this is equal to previous element. It is not, so we will swap this element. We will just take this element and update it at index, so this will be 2 and index will be 3. So index is here. Now we will check if this is equal to previous. It is equal, we'll skip. Then this is equal to previous. It is not, so we will update it at index. This will become 3, and similarly this will become 4, and this will be our resultant array. And we also need to return k, so k will be the index. Wherever we are, k will be the index. So let's start. Index will be 1 initially, and we'll start from int I equals to 1, I is less than n, I plus plus, and we will check if nums I is not equals to nums I minus 1. If it is not equal, then nums index will be equal to nums I, and we will update index. Okay, so nums is updated, and at the end we will return index. Let's try this out. Update index, and n is nums dot length. I'll try one more test case. So if we have 1 2 3 already sorted, oh, it can have negative values also. Will it work for negative? I think it will. It will work for negative also. What if there is only one element? It will not work for one element. It will? Okay. Let's submit this. Done. We'll mark it as complete. I think I'm done for today. We'll continue tomorrow.